Okay, thank you everybody. I saw already 24 people connected. We don't have a visibility on who is there, but I saw some faces. So welcome to our largest event of this year of Smart5Grid project. Let's quickly check the agenda of today's event. We will go through an overview on the state of the art of smart grids, giving a perspective from a global DSO operator, and the state of the art of the telecommunication with the DSO perspective. Then we are going through the approach of the project, so explaining for those who already or still doesn't know what we are working at, so explaining what does it mean our approach to cloud edge and especially using 5G. Then going through the framework of Core Networks API, Camara, then talking about edge computing and the potentiality of the paradigm, so orchestrator and management. And then talking about private network and our support for developers. So let me introduce our first speaker, Riccardo Lama from e-Distribuzione, who is working in distribution grids from more than 30 years with experience all around the world. Riccardo, thank you for joining us.
Thank you, Daniele. Good afternoon and welcome to this Smart5Grid Stakeholders Forum. First of all, let me thank the Project Consortium for inviting me to such an interesting event on an issue that's crucial for the distribution systems evolution. Smart grids has been a topic which is in the agenda of all the DSOs since a long time, I'd say between 20 and 10 years. And from the very beginning, communication has been at the core of smart grids. Well, to be honest, we should say that the reason itself why smart grids are needed is strongly related to issues such as voltage and protection issues that simply cannot be managed systematically without the capability to transfer and share information about electrical parameters within the network. The distribution systems have been managed through decades, unlike transmission ones, without information exchange between different parts of the MV and low voltage network. The only reason for that is avoiding costly telecommunication infrastructure that could have easily been designed from the beginning as for transmission, but wouldn't have been economically viable. To be sustainable, distribution system has therefore been planned and operated as passive system, in which the load flows only downwards, starting from the busbar that represents the highest voltage point and the maximum current, and generating a voltage drop along the feeder. By keeping within admissible voltage values both the busbar and the electrical farthest point, the whole feeder compliance and with technical rules was ensured. What happened afterwards? The development of small size distributed generation, namely PV, to be connected to the distribution grid, challenged the downwards operating mode, making it impossible for a DSO to control systematically the voltage value and to ensure the effectiveness of the protection system in case of faults along the feeders. Hence, the need for communication and the conceptual birth of smart grids. Well, that's a conceptual view, but in practice, the opportunity for a communication system supporting the distribution grid came long before its undefferable need. The introduction of remote control of the equipment, the deployment of smart metering, and the first example of automation in medium voltage feeders happened as soon as the mobile communication has become available, making it clear even before the massive connection of small-scale generation, that the distribution networks could benefit a lot from this then new low-cost connectivity. Obviously, remote control and smart metering didn't need any specific communication performance in terms of speed, latency, and bandwidth. Standalone communication, even less so. They just needed the techno-economic affordability that GSM could provide. On the other side, mission-critical applications such as online monitoring, active voltage control, flexibility services, advanced automation, and distributed protection cannot exist without high-level performances, and consequently, they couldn't be deployed unless optic fiber or other comparable wireless systems were viable. And here we come to the state-of-the-art application and to present-day TLC. But before I leave the floor to my colleague to give an insight into communication technologies, let me stress the significance of the use of broadband to support distribution operation from DSO's point of view. It is not simply a step forward. It's a quantum leap. Ultra broadband does not simply enhance the functionalities that has already been implemented. It enables a different set of application benefiting from its close to infinite potential. In a nutshell, ultra broadband is the communication technology that will allow us changing forever the fit and forget paradigm for the distribution network. But to make a joke, I'd say that previous TLC options already shifted the paradigm to fit and remember at given intervals to a real-time and ubiquitous management that will be typical of 21st century DSOs. I will mention here just two specific examples. The first one is exploiting the full value of flexibility. DSOs have now access to lots of potential service providers ready to model to some extent their behavior on network needs. Enable the exchange of services between all users to optimize network techno-economic working condition requires real-time information exchange, command and control. On a more operational level, some specific automation techniques implying fast activation cycles and systematic information sharing between components in different parts of the network cannot be performed without low latency communication. Of course, when we come to ultra broadband development, the cheaper the technology, the most versatile the solution, the most modular and plug-and-play the architectures, the better. Cooperative projects such as Smart5Grid put together all the stakeholders that are potentially involved in the process of designing future-proof solutions for the distribution networks. I'm 100% sure that we will be able to see it reflected in today's presentation. Thank you and enjoy the meeting.
Thank you so much, Riccardo, for this introduction. Very spot on the topic we are covering today. Let me switch back the presentation. So I'm leaving the floor to my colleague Sara Turco, that is working on the team deputy for telecommunication in ENEL Grids, that is coordinating all the activities of the DSOs in ENEL Group. Sara.
Thank you, Daniele. So the aim of my speech is to introduce on the fundamental importance of data communication infrastructures for the functionalities of grids, in particular in the case of ENEL Grids. ENEL today is present worldwide as a distributor in 7 different countries, with more or less 2 million kilometers of power lines, serving about 76 million end users. The aim of ENEL is to provide the best quality of service to its end users, passing from highly densely populated areas such as São Paulo in Brazil, and into the most rural areas of the planet. So, in order to achieve the best reliability, we need a high-performance telecommunication infrastructure that supports all the grid services. In this slide, we can see which are the services that the grid must support, starting from the control center, passing through the high voltage grid with the primary substation, the medium voltage grid with the secondary substations, and the low voltage grids with the end users. In this slide, several services are listed, each with their own specific requirements. We mentioned for control center, for example, all the messages exchanged for the interaction with the external system or with the TSO, and all the services related to the monitoring and management of the distribution system. In high voltage, we can mention, for example, all the messages for the monitoring of the high voltage line and the primary substations. In medium voltage grid, in addition to smart metering and all the management services, we have the advanced automation. The advanced automation is one of the services requiring the most stringent requirements in terms of latency and reliability. And the telecommunication infrastructure must be able to support the communication that the nodes inside the grid exchange in a very timely manner in order to support this message exchange. In low voltage grid, we can mention all the connectivity needed to perform the IoT message exchanges between the sensors that are installed in field. So let's have a look about the numbers and the volumes that Enel Grids today has to manage in each country of Enel. So we have more or less 40 control centers, more than 5,000 substations, primary substations, and more than 1 million secondary substations. In addition, we have to manage more than 200,000 remote control points that have to exchange data with each other in order to handle all the information needed to monitor the network. For what concerns the medium voltage grid and the low voltage grid, we have more or less 20-30,000 sensors that with an IoT network of interrelated devices that connect and exchange data with each other. For smart metering, we can mention 76 million low voltage customers and more than 200,000 medium voltage customers that have to exchange data real time in order to communicate in real time the power consumptions. So the telecommunication infrastructure must be able to support all these numbers. And for this reason, this must be able to support three things: high reliability. The reliability is defined as the amount of time during which the telecommunication infrastructure operates without distraction. For the distribution network, the reliability must be high in the communication between control center and substations. Reliability increases as the redundancy of the network increases. For this reason, we always need two paths, a primary path and a backup path that is able to maintain the communication even in case of faults. Telecommunication infrastructure must also ensure the latency. The latency is defined as the maximum communication time one way between two nodes, and it must be low in the communication between substations and control centers. One of the services requiring lower latency is the advanced automation. Considering that the time needed to perform the automation process could be only 1 second, this means that the telecommunication infrastructure must be able to communicate in a very short and timely manner. Then we also have the bandwidth. The bandwidth must be sized not only for the actual services, but also must be sized to support all the services that we will have in future. So the bandwidth must be sufficiently high in order to support the traffic exchanged between substations. So how the telecommunication infrastructure must be constructed, realized in order to support all this number, all these services, and in order to face all these challenges? Let's see. The strategy put in place by ENEL envisages the utilization of optical fiber, as optical fiber has the best performances in terms of latency, bandwidth, and reliability. So optical fiber, we can say that is able to support all the services, current and future services of the grid. But on the other hand, optical fiber is not so scalable and not so flexible, as it is a wired connectivity. Let's think in the case in which we have to connect a new point. We could have the necessity to perform some new excavations that could lead to some extra costs that could not always be so affordable. Moreover, optical fiber is not present everywhere in the countries, especially when passing from urban and densely populated areas to the most rural areas of the planet. In the rural areas of the planet, the right part of the slide, the strategy of ENEL envisages the utilization of satellites connectivity. Of course, satellite cannot provide all the performances of optical fibers, but they appear to be the most valid alternative where nothing else exists. For this reason, the radio mobile technology, 4G today and 5G in the future, is the connectivity mostly used by the distribution network. For what concerns the 4G, we can see that 4G has not the same performances of optical fiber. So in some cases, it could not fit all the requirements of advanced services, like for example, advanced automation. But it can provide more flexibility, more scalability at a lower cost. The transition from 4G to 5G will allow us to reach the same performances of optical fiber with a cheaper, more reliable, more scalable, more flexible radio communication vector. So, moreover, 5G will bring with it also all the benefits of, for example, network slicing or edge computing that will be crucial for supporting all the performances of the services and passing, allowing to achieve a fully intelligent and fully digitized grid by allocating the resources based on the specific use cases. In conclusion, the evolutions in the grid goes together with the evolution in the data communication sector. These will allow us to harmonize long-term and short-term specific needs, strategic needs, and to reach all the performances that all the services of a fully intelligent grid will require. Thank you for your attention.
Thank you, Sara. Thank you. So let me enter in the specific of what we are doing in Smart5Grid after looking at what is the state of the art of energy grid. We can see together what will be the next step, and this is what usually we do in R&D projects. Let me introduce myself. I'm Daniele Porcu from Enel Grids, and I'm pleased to be the coordinator of this project. So, collecting all the keyword of energy grids. First of all, in our project, we call grids whatever it's connected to energy, while network, it's a list of different things, like, for example, telecommunication network or telecommunication infrastructure, or the IP networking, or so on. So while talking of the next about the next topics, we will use grids to refer to the energy area, while network is communication networks. So the common keyword in to enable all these needs of the distribution grids, or in general of the energy grids, is digitalization. But before continuing, what kind of digitalization are we considering? Let me just give an example, because it's not the case, strictly the case of the DSOs or ENEL, but in general, for transmission operators or for small distributors or for energy generation, there is a control room and a series of field sites, and in between there is a telecommunication infrastructure that even if we install 5G, so we are going ahead with increasing the performances, increasing the bandwidth and reducing the latency, it will stay the same principle as a telegraph invented maybe 200 years ago. So why we are talking about 5G based cloud edge computing? We are making a paradigm shift. Since the telco infrastructure with 5G is a digital infrastructure, we are able to move the computational power from the field side to the so-called edge. So installing a multi-access edge computing device inside the telco infrastructure or in the border in between, and through the virtualization techniques, we are able to dramatically reduce the latency, because the more we are closer to the information, the lower will be the latency, and that's how we can implement this edge computing using the 5G technology. So in this chart, we can see the open experimental 5G platform we developed in a Smart5Grid project, where on the top layer, the platform layer, we are enabling the developers to implement their own artifacts by means of a model of network application. We will see in the next slide what a net application is. We implemented an open service repository to collect all the developments, and also having a single entry point to the platform, and a framework for validation and verification to accelerate the testing of the artifacts. So this platform is connected with the virtualization and telco layer. So we saw that the edge nodes is inside the telco network, the telco infrastructure, and this machine is hosting the network application that is bridging between the telco layer and the energy layer. Why we talk about bridging and what is the difference between different technology is that being inside the telco network and the telco layer, we will see in the course of the presentation, we can access not only to our artifact, our developments, but also interact with the core that we are in a transition period. While you already see in your telephones that the radio part is in 5G, behind the scenes, the core network are still not standalone. But as soon as the core network will be available, a series of services, and we will see in the next block of slides with my colleague, a series of services and APIs will be made available to allow developers to interact with the structure. This means that the telco infrastructure can become more flexible and adjust to the need of the distributed infrastructure, not only for distribution or transmission, but also for example, mobility or distributed generation. Okay, we mentioned the network application. As a first high-level concept, we can say that it's a paradigm that it's allowing us to simplify the 5G complexity. Because, yeah, talking about machines and hardwares, there is a series of steps that we had to face with while implementing the project. And this concept is really giving a strong simplification. In this way, this is an example of generic network application where we see a list or a chaining of VNFs or microservices that are in charge of different functions for my generic application. For example, the slicing, that is one of the peculiarity of 5G, that allows to dedicate a band to an utility, for example, to be able to guarantee the reliability of the communication layer, as we discussed before with Sarah, or for example, a routing functionality. If I am a developer and I can concentrate my attention to my automation algorithm, for example, I don't need to know how a slice manager is working. Maybe someone else developed a slice manager, and it can be available in a common and shared environment, or it could be available in the market. By means of chaining all these microservices, in the future, this approach to network application could simplify this integration between different parts. Then other parts of the application are, for example, the requirements to understand in runtime environment if those computational requirements are guaranteed, or there is a need to move the application, for example, from the edge to the central cloud, or to back up too much overloaded edge node with another edge node. So all these things can be automated by a series of components of the infrastructure, and the network application contains all the need for this application to run. Now, let me spend 2 words about describing what is the project about. It's about investigating the potential of 5G and edge cloud computing on the power energy industry. The project started 2 years ago, 2.5 years ago. We are almost finishing our period. The end of the project is foreseen for next April. We implemented 4 real-time demos. Later on, we will give more details on those pilots. And all the pilots are already up and running and collecting data. So the next step will be continuing the experimentation, improving the performances, because in the meanwhile we are checking what could be done better, or what are the turnaround to solve some issues. And by means of the platform, we can easily check and develop our network application to perform better. The consortium involves 24 international and European partners, half of them are SMEs from different areas, from, for example, energy generation or different expertise in computation and so on. We have with us 2 DSOs and 2 TSOs, and I think it's a very, very good consortium to work with. And let me use this opportunity to say a big thank you to all the partners involved for the results achieved so far. So let's move ahead with the next presentation. Let me leave the floor to Andres Cárdenas from the Foundation IPTO, and is also assistant professor in the Polytechnic University of Catalonia. Andres, the floor is yours. Thank you.
Good afternoon, good morning, good afternoon, everyone. My name is Andres Cárdenas. Thank you, Daniele, for the presentation. Today, I'm going to try to give a brief overview about what is the new trend in the telco side. So what should be the new approach in the point of view of the operators on how to expose services to developers, to verticals, in the sense that Daniele explained before. The network application should be deployed or should be designed by verticals and developers. But the idea is how these services can take advantage of the infrastructure of the operators, of the network providers. So the idea today is give us some aspects about what is the initiative and why it is the purpose of this initiative. Then I move forward to the idea of the framework and the architecture. And then I'm going to finalize with the main roles of the stakeholders in this initiative. Okay, so what is Camara? So Camara is a new initiative supported by Linux Foundation with a collaboration with the GSMA. So the idea or the mission of this new initiative is try to foster the definition and the designment of the new open and standardized APIs. So the idea is to join several partners, not just operators, but also partners like communication service providers, hyperscalers, solution integrators, vendors, and so on. Try to define in a common approach in order to start defining some aspects of some insights on how to expose, how to take advantage of their solutions in the point of view of the verticals. So in that sense, at the beginning of the approach, Camara has adopted an open source approach. It means that all the definition of these APIs should be open and could be tested by developers in terms of they can access to the information, and then they can realize how are the methods, what should be the inputs required, what should be the outputs, and then how the services could be integrated with the operators or with the platforms. So what are the aspects that Camara is mainly addressing? We have three the main ones. So the first one is the scaling. The scaling is because all of the verticals or the app developers requires to deliver their services in different kind of markets. Maybe all of these markets are managed by different kind of operators. So they need to put their services on different kind of markets. So they need to have a fast scaling in this kind of markets. And also having this scaling in mind, they need a kind of consistency. What it means consistency? Consistency, it means that they need to attack some interfaces of these operators, but they don't need to use different kind of specifications of the interfaces or different kind of interfaces in each market or in each country or in each operator. It should be really difficult for them in order to develop their services that should be exposed on that operators and the time to market should increase. So they need a kind of consistency, and also in the sense of developing, they need simplicity. So the idea is that all of the complexity in the telco layer or in the telco side should be abstracted for them, in terms of they don't need to know what should be the role of specific orchestrators or specific function managers in order uh, to coordinate the applications in the computing side and so on. So they don't need to know how to do this. They need to just to have a general overview of how they can exploit these functionalities in the point of view of their services. So next slide, please. So in that sense, in the point of view of the operators, they need to be aligned with the evolution of the verticals. Now, all of the verticals or over the top service provider, they are moving all of these services at cloud native solutions. So in that sense, excuse me. Okay, I hear something. Okay, in that sense, the operators also they need to evolve their infrastructures. They need to move all of these new kind of telco functionalities in the sense of the point of view of the cloud native solution, to move all of these solutions and kind of all software to be deployed in the cloud systems. The reason is because they don't want to be just a simple transport networks that they carry the data from the user equipments to the end applications or the over-the-top applications. They want to monetize their services, and what are kind of services they want to monetize the revenue in the terms of networking, in the terms of computing capabilities, for example, in the edge side. So they need to enhance these characteristics and they need to expose to the verticals. So in that sense, we have two main questions. If they want to monetize, if they want to be prepared for the next communication paradigms or new kind of services in the trend of the 6G networks, the questions are how to enable this smoothly integration between services in the one side or developers and the operators in the second side. So how to take advantage of these integrations. Next slide, please. So in that sense, GSMAI proposed a new framework that they call Open Gateway Network as a System, as a Service System. It's a framework that the main focus is to define a common group of APIs that expose the telco capabilities of the operators. So in the point of view of the MNOs, it means that the MNOs can expose several functionalities in the sense of the networking and the infrastructure, and they can monetize these parts. Also, they can have more flexibility in the sense of managing the quality of service of the applications, or maybe in the term of change of the role of the specific services in the point of view of how to program these services. And also they want to has more revenue in their investments, like in the fiber optics or edge computing sites, or in the deployment of the distributed 5G networks. In the point of view of verticals, it means that they can have more control in their services. So now all of the services are based on the best effort approach. It means that all of the data goes through the mobile networks and then can reach to the services without specific characteristics like quality of service, or specific isolation, and so on. So these topics now are addressed by the 5G networks by integrating network slicing, by integrating a specific quality of service regarding specific network slices and so on. But in the previous generations, the services just have the best effort approach. So now they can manage in a flexible manner this kind of how to treat the data of their services. So in that sense, they can enhance the user experiences, and also they can contribute and then can enhance, provide new kind of services for the future networks. So what should be the architecture? This is the main picture provided by Camara initiative. So in the below of the picture in the bottom, we have all of the telco infrastructure. It means cloud infrastructure, network infrastructure. In the network side, we have the 5G core, the transport networks, the radio networks. So all of these network segments have their own interfaces. So all of these interfaces are defined by the specific standardization bodies like 3GPP, GSMA, ETSI. So all of these infrastructures are managed by the operators. So in the point of view, for example, in the Smart5Grid approach, we can put here the platform in the one side and the telco APIs, because in the sense of the Smart5Grid platform, we can expose some capabilities in order to design the applications and then put and manage their life cycle. And also we have the telco APIs, how these applications should be deployed and how these applications should be configured inside of the network infrastructure. But now the next step is how to expose some of the capabilities of the network infrastructure to these applications or to the verticals. So in the next layer, we have this kind of group of APIs. These APIs, previous slide, please. This one, thank you. This kind of group of APIs represents how the verticals or the applications can consume some services that are exposed by the MNLs. For example, they can consume some services regarding to the routing, to the security, to the billing, or maybe in terms of the services itself. So in the one side, we have the Camara APIs that are more oriented to the services, and we have another group of APIs like you could call operate or open APIs. This is more related to the management of and orchestration of these services. And below we have the technical APIs, is more standard APIs. Next slide, please. So in that sense, here we have the common view of the Camara initiative. So in the top of the figure, we have all of different kind of verticals that can consume this kind of services. So in the role of these customers or third parties should be, it's that they can take advantage of the services exposed by operators, and that they can design their applications in terms of provide some kind of new business or new kind of premium services to different kind of end users or customers. So the idea is that they can design their solutions oriented to the end users. And below we have the common and generic network infrastructure provided by the MNOs. So all of these technologies are defined by the standardization bodies like 3GPP, GSMA, and also they define how these telco functionalities should be integrated in order to be exposed. So the idea is Camara said, okay, we can abstract all of this complexity that provides the MNOs, but the role of the MNOs is to translate these functionalities. It means that, okay, they have some telco functionalities in their infrastructure, but they need to translate in a more friendly manner their functionalities in order to be consumed by the verticals. So the idea of Camara is to have kind of middle interface that expose a user-friendly interface, and then below they can translate all of this information in the terms of the complexity of the network infrastructure of each MNO. That each MNO has their own solutions, has their own interfaces, and has their own infrastructures. Next slide, please. So the main role of Camara is define the APIs. Maybe now we have a basic group of APIs that we are currently defined, but they are working on on the design of more additional APIs. And also the role is to define the roadmap of this API and how should be integrated across the different operators or different customer service providers, communication service providers. Another point is that they need to have a common steering committee in order to define all of these APIs, to have a kind of harmonization between the project in the sense of that trying to reuse the efforts that were provided by the different operators in previous years. The idea is to all of these kind of efforts trying to harmonize and align in a common and standard way in order to define these APIs. And the lastly is to define documentation regarding these APIs in the sense that all of the verticals or all of the customers can be aware of these kind of solutions and then can start testing and developing their solutions based on these interfaces. Next slide, please. And as a conclusion, the Camara is leading a new paradigm in the sense of how to create a new trend on the use of the services in the operators platforms. So the idea is they need to monetize and also they need to expose some kind of flexibility to the services. Then the services can reuse and can take advantage all of these kind of information or functionalities exposed by the operators in the sense of how to manage or how to act depending on this information by using these services in the sense of providing some kind of services to the end users. So in the point of view of the verticals, they can take advantage of this kind of network as a service system to evolve their business so they can reduce their development operations procedures in the sense of they have a common framework, they can define the interfaces, and they can use wherever the market they want to deploy the applications. And it means that these services are more user-centric. So this is important because they can act depending on the context of the users. For example, if one user is experiencing some kind of mobility issues, they can act or their services can act depending on this context. And this kind of service should be customized. So this is a new kind of evolution of this network applications approach in the sense of the next future of next generation of networks. Thank you. This is all for my side. Glad to hear from you.
Thank you, Andres. Just a last comment from my side. This presentation, even if Smart5Grid is not directly participating as a project in Camara initiative, we are lucky enough to have several colleagues who are part of it, and it's also allowing us to have an overview on what's going on outside of the project boundaries, and in the sense that the network application will be able to access the API of the core. There is already some standardization approach to have a common layer. So network application, even if Camara initiative is giving a kind of standard layer, maybe the service is not like complete. So with the network application, we could include some VNF that is leveraging on this API and include it in our network application. So it was a way for us to show you all what's going on outside of the project boundaries and what are the potential. We will go back to the same idea later on. Thanks again. So let's move ahead with our presentation, and let me just briefly mention what we are doing in our 4 pilots. In Italy, we are supporting the smartphone selection automation paradigm with an IP monitoring tool to verify and check the reliability of the underlying communication infrastructure. And in parallel, we are also checking the implementation of this automation using 5G as a media. Also in a blended way between 4 and 5G, because of not all the sites are covered by 5G connectivity. In Spain, we are implementing safety, real-time safety monitoring tool using a network application. All of the demos, of course, are using network applications. And this is a very specific demo that it's leveraging on private 5G infrastructure. We will see later on what does it mean to use a private infrastructure. In Bulgaria, we are using a network application for real-time and millisecond precise management of distributed generation plan, together with enabling the predictive maintenance. And last but not least, our Greek-Bulgarian demo, and this is what we will talk about, that it's a pilot in which the network application is used to virtualize some physical devices installed in the grid. And for more insight and more information about this demo, we have here our colleagues Michalis Rantopoulos from OTE, the major Greek telco operator, together with Dimitrios Brodimas. I don't know if Dimitrios could manage to connect today, but Michalis, the floor is yours.
Thank you, Daniele, for your introduction. I have to say that we prepared this presentation jointly with Dimitris Brodimas from IPTO, which is Greece's independent power transmission operator. However, he notified me due to a personal matter. He was not able to participate and present with his own words the energy part of this presentation. I will try to give an overview of what we are doing and the results achieved so far at use case number 4, which is about the real-time wide area monitoring of a cross-border area between Greece and Bulgaria. So there are 2 telco operators involved, as OTE from Greece and Vivacom from Bulgaria, which handles the measurements from ESOs, which is correspondingly the transmission systems operator of Bulgaria. So the scope of use case number 4 is the real-time monitoring of a geographical wide area where cross-border power exchanges take place. This interconnection flow between Greece and Bulgaria is monitored leveraging the advantages that the 5G communications infrastructure provides. There was a very good introduction at the beginning, I see, from Sarah regarding the benefits of 5G. I have prepared a few words myself on this. There are 2 critical elements involved in the setup of our use case. The first one is the phasor measurement units. Those units are installed by the IPTOs, the transmission systems operators, and they measure grid current and voltage by amplitude and phase at several substations or nodes of the transmission power system. These measurements are broadcasted with high granularity. We've seen on site that there are sent 50 measurements per second. And they're critical, those measurements are critical for the correct monitoring, precise monitoring of the power grid operation. In our use case, the two PMUs are located in Thessaloniki particularly for Greece and Blagoevgrad regions from Bulgaria. The measurements produced by those substations will be used as a monitoring process of the newly established regional security coordinator in Thessaloniki area in Greece again. The second element involved in this process is the virtual phasor data concentrator, which is developed for the data gathering process according to C37.244 standard. The utilization of 5G between the PMUs and the virtual phasor measurement unit fulfills the critical constraints of this use case. Next slide, please. Yes, this is the legacy architecture, as you can see. We have the interconnected systems between two transmission system operators. And please proceed with the animation so that you can see the PMUs attached. And with this hierarchical approach, a set of PMUs concentrate the readings to the PDC, a local PDC. And then another PMU is integrated, which integrates the readings to a higher level PDC, and so on and so forth, till the measurements reach the common control room. It is easily anticipated that such a cascading hierarchy causes significant delay, even though optical fibers are used. Each step adds a significant amount of delay to the whole process. So we'll try to simplify this. Please proceed with the animation with a creation of a virtual PDC and the utilization of 5G networks from two operators. So we have a simple connection. The concentrator, of course, gathers from multiple points those readings, and the 5G ensures that an absolute wait time criteria of 40 milliseconds is safeguarded, is kept for the correct reading of the measurements from the concentrator. If this value is exceeded, the PDC by itself discards those measurements. Next slide, please. This is a simple diagram. We have now the advantage over the legacy solutions. We have a direct communications between the VPDC and the PMUs over 5G networks. Optical fibers are ruled out of the equation. We don't need them anymore. We're trying to move into more cost-effective and direct solutions. Okay, next slide, please. This is the call flow path. This is our realization, where the interconnected systems can be seen on the left part of the side. These are the power grid systems between Greece and Bulgaria, correspondingly with the country's flag. PMU1 is broadcast the readings from Thessaloniki substation through Cosmote's 5G systems to the edge cloud server. This part, the edge cloud server part, is hosted in Bulgaria, which creates a challenging part, particularly for the reading sent from the Greek side, since we have to involve the international carriers for the transport part of the transport path. This is not the case for the Blagoevgrad PMU measurements, since one can say that these are kept locally. They are transported from 5G non-standalone network of Vivacom through a private APN created by Vivacom's colleagues to edge cloud server, which is kept, we can say, locally in Sofia, Bulgaria. This effect will be demonstrated in the next slides, where the corresponding measurements are shown. Yes, these are the comparative measurements from field locations, and this is particularly for the Bulgaria demo. We refer to an absolute waiting time criteria of 40 milliseconds. This criteria is highlighted with a yellow dotted line. It is at 80 milliseconds because, according to our testing plan, the Zabbix servers hosted centrally at Vivacom's premises measure the round-trip time. Basically, what they do is they send ICMP responses, and which measures, it's a round-trip time. So roughly, we say this round-trip time is twice as much as the criteria we would like to fulfill. In almost all cases, as you can see here, the criteria is kept safely between the limit. So this in a sense can be portrayed as an more edge-like application realization. However, when we move, please go to the next slide, to the Greek demo, which we have the Thessaloniki PMU measurements broadcasted, we can see that this the latency, the average value of the latency exceeds our criteria. We have performed investigations on where the majority of the excessive delay is focused, and this is due to the roaming interconnection. This is due to the involvement, as we saw in the call flow path earlier, of the GRX interconnection path. It's something that we do not have a direct effect in order to do something and minimize this latency criteria. There are some other options considered in order to let's say, improve the quality of this, the latency criteria, which is, one thought is to use a private APN, to use a Cosmote SIM card for Thessaloniki PMU. We are not particularly using this GRX interconnection. We'll be using some other interconnection routes, which, according to the third site survey to be performed in the forthcoming period, we expect to improve below the yellow dotted line our measurements. Also, you can see after, these are actual live measurements, and you can see a sudden drop of the readings obtained. This is due to the fact of a manual intervention locally in the substation. These things might happen. We are dealing with real live situations and problems. There was a complete, let's call it, non-network issue that caused this absence of measurement, which it has been fixed now. Next slide, please. Yes, the observations, a summary of the observations. There is no significant delay for the Greek demo inside Cosmotes mobile network in the RAN and the transmission side till the data reaches the gateway server. As we said, the main problem lies on the GRX interconnection side, since the user plane data follows through the usual roaming data path, which causes this issue. The Bulgarian demo has, as we said, a much better performance of latency. Yes, and the future improvement is to test the Greek demo with a Cosmotes SIM card instead of a roaming Vivacom and measure this, this effect on latency.
Thank you, Michalis, for the presentation. I think it's a very spot-on example on what we mean for virtualization and how 5G can support. Just to remember for everybody that the Mac server is installed inside the telco infrastructure in Vivacom Bulgaria premises, and we are covering a very particular use case in which also the cross-country connectivity is tested. So we are not only solving or tackling a problem of the grid, of the power grid, to control and monitor the frequency and the phase shifting in between the two countries, but also tackling with several issues concerning cross-country telecommunication infrastructure and the way how virtualization can support it. It's on one hand reducing the number of devices from the field device till the central control room that is based in Thessaloniki, and opening for a not so far never exploited situation of having this extreme quantity of samples. You talk about more than 50 samples per second that today
Yes.
it's not realistic to collect. So as also Ricardo mentioned, it's a quantum leap. Next step will be, for example, I'm just thinking loudly, but it's an expectation from my side and a stimulation for the audience to realize, for example, a machine learning algorithm that is able to recognize the patterns of how the frequency and the phases are changing and varying to prevent in the future some disruptive phenomenon. So leveraging on the availability of the data that so far it was not there, and not with such a granularity, we could really change the rules on how we are implementing devices. So this is only an example, a practical use case, but who knows, in the future, any kind of application of such technology could be available. So thanks again for this presentation. If you agree, I will make a few minutes break, 5 minutes break. Let's meet at 3:45, not to exceed the given schedule. Okay, so some physiological break for everybody. Let me switch off the microphone and talk to you in a while. Thank you. Hello, everybody. So we are back from our coffee break. It took longer than expected, but let's move ahead with the presentation. I hope Michalis is connected and ready to start.
Hello, Daniele. Thank you for
Hello.
setting the stage.
Thank you.
Good afternoon, everyone. So I would like to talk about edge orchestration, the benefits we can have by this, and the orchestrator we used in Smart5Grid. The Smart5Grid paradigm poses new challenges to communication network, requiring more flexible, orchestrated, and low latency networks to transform the current power grids to more evolved smart grids with features like online monitoring. New tools need to be implemented. Let's see now, in the framework of 5G and edge cloud continuum, the benefits of having an orchestration solution, especially when on the device layer, as we can see on the figure below, we have smart grid use cases. We can see different end users that they need to access the power grid network as well as the 5G network. And on the top, we have an orchestrator, nearby one controller, deploying the services and providing benefits such as reducing the total cost of ownership by using traditional and modular servers, as well as applying the edge computing paradigm by deploying network applications closer to the end users, as we can see here on the edge layer. We also have the benefit of using a common network model. We can see how the different end users can be leveraged by one orchestration solution and inherent observability as the edge platforms provide telemetry towards the controller, the orchestrator controller. We can monitor as users the whole infrastructure as well as the applications. More specifically about the orchestrator we used in Smart5Grid, Nearby One has been leveraged as it can manage the infrastructure, the network functions, and the applications, can be vendor agnostic, and can manage public and private clouds. For the use cases of Smart5Grid project, on the next slide, please. We can see from the orchestrator's web interface how we have onboarded cloudlets, servers with cloud native technologies. We can see 2 servers in Bulgaria for one use case. For another use case, we see another server in Italy. And on the next slide, we see the onboarded and deployed services, some specific network applications for the use cases. So through a single pane of glass solution, we can manage both infrastructure and applications. And main features of all this concept, as we can see on the next slide, is a unified configuration management. We have a friendly UI to deploy the applications. We have defined configurations across different clusters, a unified management for network functions, for virtualized network functions and physical infrastructure. We can manage the lifecycle of applications and infrastructure very easily. We can roll out to a new version or return to a previous version. We can instantiate, terminate, or upgrade the services. And of course, the benefit of full observability.
by leveraging the observability stack as a service using open source components like Prometheus, Thanos, Grafana for dashboards. End users from the web interface can have full observability of the whole system. Before I finish my presentation, I want to mention two real use cases. For example, the smart substations, how they can benefit from the Smart5Grid paradigm by implementing an orchestration solution for the edge applications and service. These benefits can be listed as monitoring and securing the base stations. We can have automatic power grid fault detection and real-time wide area monitoring. And for the other real use case for the virtualized substations, on the next slide, where the logic of the substations now is running in softwares and in virtualized layers, we can achieve lower latencies. We can collocate auxiliary services with the main critical services and macro and micro orchestration from a single pane of glass, as we saw earlier from the orchestration solution. These are from my side from the edge orchestration. The floor is yours, Daniele.
Thank you so much. It's indeed very important to underline one aspect that is not part of the research in Smart5Grid, the orchestration, because NearbyComputing was bringing its own product. It's already working, and in last example, Michalis illustrated how the orchestration is working in other implementations we see in Iberia Peninsula with the national TSO, telling that this approach it's already there. So what we are developing and what you are experimenting in Smart5Grid, it's ready to enter in the market. So even if the core network is not available, the infrastructure it's ready for that. So we are not talking about very far future, but it's already working and ready to be implemented. So thank you again. The next presentation will be held by Nicola Di Pietro from Athonet, from HPA Group. Nicola, it's among all the IT engineers, he's a mathematician, so he's expert in numbers. But apart the joke, is a long score and long track in telecommunication field for both academic and industrial institution. So Nicola, the floor is yours.
Thank you very much, Daniele, especially for recalling my my education specifics. Anyway, hello everyone once again. Yeah, as Daniele kindly mentioned, I work for Athonet, which is part of Hewlett-Packard Enterprise. Athonet in particular is active in the field of mobile core networks that we have mentioned today already. And if I have to summarize in one sentence what we do within HPE is that we develop fully virtualized 4G and 5G mobile core networks, and based on that, related solutions, both for public networks, but also for private networks. And this is the topic of today's presentation, actually. So please, next slide, and Daniele. Thanks. So first of all, we have already started explaining it today, but one usually starts with a question, why 5G? Why don't we do the things we already do or that we already presented actually with 4G? And the answer is that 5G, it's natively designed around services, and it can actually be seen as a business-to-business technological revolution. This means that 5G is conceived to be, we could say, infrastructural to businesses and to new production systems. in the sense that it's not just a support to productivity or to operations anymore, but it's actually an enabler for new ways of producing, of manufacturing, of delivering services. And this also translates into the fact that new customers, to those who provide 5G infrastructure or 5G technology, new customers are the so-called vertical sectors. They go beyond what the national operators are and will be in the future, and are actually entities from private or public institutions that now want to have 5G technologies and to use it for the purposes and the services we mentioned. And I put in this slide a list of these sectors. We have the manufacturing sector, the utility sector, government, healthcare, and so on. Thanks. We can move to the next one. Thank you, Daniele. And so, as I have mentioned, we are moving from an ecosystem in which there are not only public 5G networks anymore, but we also have private 5G. And it's actually becoming a common practice for common businesses of different sizes, by the way, to have their own 5G networks. And the whole ecosystem is moving from having relatively few, right, just a handful per country, nationwide public networks, to actually a plurality of small, if ever this term can apply, but small private customized networks. And the role of the operators is not necessarily changing. I mean, they're still going to be there. In many countries, the national operators are those who concretely manage and even rent the spectrum for other uses. But there will exist these new players in the market. Please, next slide. Thank you. And these private networks are becoming a reality to the point that even the 3GPP, so the third generation partnership project, which is the worldwide organization that standardizes mobile networks, has introduced private networks in the 5G standard. And they're actually called non-public networks in the standard. And to summarize it in one slide, we have two families of private networks, of non-public networks, the so-called standalone ones, standalone NPNs, in which the whole network infrastructure is owned or at least controlled by the private entity that installs it and uses it. And then there is the so-called public network integrated NPN family, PNI-NPN in the acronym, which is a family in which private networks are actually obtained as network slices, so virtualized, logically separated slices of network carved out of the public of a public network. And if we briefly compare the difference or the benefits of adopting private 5G networking compared to public 5G in this kind of deployments, keep the standalone NPN example in mind, for instance, well, we have these bullet points, right? So first of all, a private network deployed by a private owner for its own purposes within its own facility allows for, first of all, the localization of data. Data remains local, and this enhances privacy and security. Then we have, of course, for the same reasons, reduced latencies in the data transmission whenever needed, especially for edge computing that we have also mentioned before. We have, of course, an optimized radio coverage when I can just deploy my network equipment, including the radio equipment for my purposes, which again optimizes and improves the whole performance of the network. And then globally, we have more control that an owner can have on a private network, and therefore reduced uncertainties of the network operations and reduced service disruption. Next slide, please. And of course, private networks offer the same features and advantages, let's say, that we have mentioned for 5G in general so far. In particular, also private networks, they are made of the same network components, even if perhaps scaled differently than public networks, and they do have this capability of exposing control plane functions and services to external parties. In other terms, also in the framework of private networks, network application can interact with the 5G network itself, and have some degree of control over the network. In this case, the standard defines this interaction as happening through so-called application functions. To simplify, we can think of network applications as application functions from the perspective of the 5G infrastructure. And the network, of course, exposes interfaces to these application functions. We saw the Camara framework before, and part of the Camara framework are also the interfaces exposed directly by control plane network functions of the 5G core network. And through these interfaces, application functions and network applications then in our framework can interact with the core, with the network itself, to perform the four sets of actions summarized on the left of this slide. For instance, to retrieve events notifications about users concerning loss of user connectivity, their mobility, and so on and so forth. Application functions which are, again, external to a certain extent compared to the 5G perimeter, they can still trigger device actions like device activation or the transfer, the sending of a feedback message, for instance, after certain operations are run, and so on. And I would even say, more importantly, network applications as application functions can retrieve network analytics from the network. Nowadays, this is extremely exploited as a concept, right? And then they can even configure certain network parameters whenever they are authorized to do it, of course. But yes, but they can. And these parameters involve routing information for specific traffic, quality of service parameters, and so on. And next slide, please. And the other feature that I wanted to highlight is that, again, there are several possibilities to implement a private or a non-public network. Related to these ways, there are different possible architectures. And a possibility is the one of a hybrid deployment, in which we have a centralized core network, which per se gives also access to remote clouds and resources, but we can move to the edge, whence the objective hybrid in the name, centralized plus edge. We can move to the edge the user plane and the user plane function of the 5G. This allows for enabling edge computing, first of all, because all the traffic remains localized so that latencies are reduced. There is also a reduced possibility of backhaul bottleneck because we are reducing the amount of data transferred through a centralized, for instance, user plane function. And we have enhanced security as for the fully local deployment that we mentioned some slides ago. And I'm mentioning this because it is also what we apply, at least in use case 1 of Smart5Grid, which is depicted in the next slide, at least its architecture. Thank you, Daniele. And to summarize, I don't want to go into all the details here, but what I like of use case 1, which involves Athonet together with Wind3, the Italian operator for what concerns mobile networking, what I like is that we are implementing edge computing, we are implementing the hybrid deployment I mentioned before, and we are somehow showing as a proof of concept the feasibility of public network integrated private networks. Because what we're doing for use case 1 is to bring an edge node that corresponds to what we saw before, to the set of user plane functionalities that allows for keeping traffic local wherever needed. And this edge node is capable of directing towards an edge server where use case 1 network application is installed, all the traffic coming from the field devices without traffic having to flow through the central location. So once again, time did not allow to go into all the details of the use case and of the network application, but the highlights are that we were able to implement this prototype, if you want, of public network integrated NPN and edge computing facility. I didn't mention it explicitly, but the network, the radio access network and the central core network, part of the overall 5G non-standalone network used here, are those that are the public equipment and components of the Wind3 network itself, which is also remarkable, at least in my perspective. And I think I reached my conclusions here. So we have said that private 5G is a reality. It is becoming common practice for common businesses to have their own 5G networks, and the standard adopts also this view. And I leave here an open question: how many networks are we going to have in the world? Are we talking about millions of deployments? Maybe that's a lot, but Athonet alone has already something around hundreds 4G and 5G active licenses for private networks, and this will definitely going to increase. The important message is that we're talking about a bigger, let's say, magnitude, bigger number than the public networks to which we are accustomed in our experience so far until 4G. And then once again, a highlight on capability exposure and the possibility for external parties to interact with the network, to have access and control over it to a certain degree. And that's it. Thank you very much. I give the word back to you, Daniela. Thanks.
Thank you, Nicola. Yeah, of course, we couldn't enter in specific detail, but we are available for any further, I don't know, clarification if needed. So next presentation, for next presentation, I will call our colleague Helio Simeão from Ubiwhere. He's based in Portugal. Hi, Helio.
Hi, everyone. I hope you can see me, because at least I can't, but I don't know. Is everything okay?
Yes, please,
okay.
The floor is yours.
Perfect. Thank you, Daniela. Thank you, everyone. So,
we are 10 minutes past 6. We have 20 minutes to finish the event. So I will ask you to
speed up.
to speed up a bit.
Fair enough.
Not much.
So, yeah, thank you, Daniela. So just as a wrap, or a lot of what we've been presenting to the audience. So a lot of 5G and opening the network to developers. So I'll try to briefly talk about how can we help you developers, so SME startups, to join this ecosystem. Okay, and how what the tool that we created during the project, how can you do that? Just a very brief. So I think we can. The synergy between the 5G network and the energy grid is quite it's there, right? So it's we have a lot of distributed infrastructure across the country. So this is something that opening. I mean, it makes sense, right? It's sometimes even co-located, the antennas and all the equipment from the radio with the energy equipment. So we can also use this opportunity to further improve the synergies. We can skip. We can go a little bit advanced on this slide. So basically, as we can see in this, we have basically a concept of network app. So this is, I guess, a fancy way that we have to tell you that we can help you to translate all the functionalities and a lot of the good stuff that comes from the cloud. We can also put this on top of the 5G network. Okay, so essentially is this, as you can see, so leveraging a microservice architecture. So we want to reuse, and also there's challenges in terms of not only reusing which functions, but also where should these virtual network functions be placed, if it's on the cloud, if it's on the edge. Keep in mind that every time you go further away from the cloud, the resources are more scarce. So all of these things, so you could run something in a rack server, which is still a very heavy capacity, or in a Raspberry Pi, or even a microcontroller. So this is all questions that edge deployments have to be addressed. I mean, in edge deployment, and also of course to reduce the level of knowledge required of the 5G network, so that you basically, from a developer point of view, we want APIs. We want the network to be a box, a black box. We can go ahead, Daniela, please. So in this sense, let me introduce you to our platform, so the Smart5Grid platform, where basically we have integrated a very nice user interface, so for you guys to access, and also the integration with the telco layer and the energy layer. So a lot of the stuff that was presented, for example, from NearbyComputing, so we are using in the verification and validation phases, we are using their components from Atos as well, the verification engine. So for example, if you use let's say the pattern, not the pattern, the let's a template, let's put it like this, for network app that we chosen, the descriptor, basically you can be sure that if you follow our instructions, and you can get our support, by the way, you can use this to test and validate what you did, and also to have more assurance that whatever you're doing, it will or is supposed to run, let's say, in a live environment. So in that sense, I want to highlight that we offer a free testing environment. So this is not just some user guide, which we will of course have. You can actually put things to test. You can actually get feedback from the tests and learn something new. So yeah, just in the next slide, we have a sneak peek of the, so this is the just brief presentation of the several phases. So you do all the development, you can, the verification phase, you will check a lot of the syntax errors, a lot of the more basic stuff, let's say, and also if all the VNFs are correct linked and so on. And then on the validation phase, it will actually try to deploy your network application into a testing infrastructure. And of course, with this, you get more assurance of if things are where they should and working as they should. In the end, the network app can be available in a public service repository, the OSR platform, where you can check your network apps and all the versions. Last but not the least, so you can have a sneak peek. This is what we created during the lifetime of this project, and this is something that you will be able to interact with. Okay. So just as a wrap up, basically, these sort of artifacts allow you to what it's, I think, commonly referred to, write once, deploy everywhere. So this is something that it's very interesting, especially as we see in previous presentations, that a lot of the infrastructure can be replicated and spread across the country. So this is something that will allow you to easily scale what you're doing in terms of your application. Highlight again, a free testing environment. Okay, so this is something that we basically, please come play with us. We have all the toys. Make sure that you join. Also, we can help you to build and certify under the tests that we perform your network app. And of course, I think this is quite a unique opportunity where we have in these big consortiums, we have experts from different domains. So for example, from the software, infrastructure, telco, energy domains, and so on. So this is, I think, a very good opportunity that if you're an SME or a startup that wants to dive in this more digitalization and virtualization topics, please consider participating with us. But then again, I know that Daniela will refer to this later on. So that's it from our side. And hopefully I didn't keep it too fast, but
yeah, thank you. Even if it was a little bit too fast, let me underline a few points that and I will open to my presentation for the final block of slides. What are the key features of network app approach? So on one hand, we are fostering, as I explained in the opening of this event, fostering the core network feature to be integrated with the application. So the network application, it's allowing to either develop your functionality and integrate it with the interaction with the core, simplifying the 5G complexity. What I mentioned at the beginning, it became clear during the course of the presentation that there are different layers, different approach, different implementation, but the network application approach allows to abstract and not really be connected to a specific architecture, and the software and the code can be reused independently from the what is the platform used. And then you can focus on the development. So it's a support on going directly to the core of the problem without taking care about, for example, how to build a slice manager. Someone else will take care of it. Or if you are expert to develop a slice manager, you can, in the future, maybe there will be a market for it. So developing your own tool to be shared with developers and create a kind of micro market of such services dedicated to developers. And then combining multiple microservices, we talked about this several times, but this is the way how to simplify and to combine together different knowledge domain. Then the orchestration and operation approach, as described by our colleagues from NearbyComputing, it allows a centralized management. This is when the development is concluded, the network application it's validated, verified, and we want to go online with the software. There is the opportunity of having a centralized management, and also the opportunity to decide if that specific application is better to be run in the edge or in the cloud or in the next available edge node, or what is the best solution in that specific moment. And it's fostering scalability and replicability. I'm thinking about the implementation in, for example, Bulgarian pilot, where we are using a network application for managing a wind farm. Maybe the owner of this SMA will decide tomorrow to acquire a new power plant in a different site. You just need to install simple probes all around the wind factory and replicate an application. So from a concept point of view, it's easier to replicate the same scenario when we talk about software, rather than installing a complex hardware infrastructure. And then we are leveraging on a flexible infrastructure such as the 5G. And last but not least, accelerating the implementation as quickly, maybe it's too much quickly, Elio presented. We created an open service repository as a single access point for our platform, from which you can click on a test button and perform the integrated verification and validation of the network application. So performing an automated series of tests to check if the application is formally correct and if there is no critical errors at runtime, because the application will be instantiated in the edge node and checking the execution of that application. Now comes the opportunity for the developers. Let's open the advertising side of this event, that platform are open for you. We just finalized the implementation. We are just correcting the few points in the registration form, but we will circulate the link for entering that platform so that you can build and test your own network application and start to get familiar with this new way of handling virtualization of devices, and distributed computational model. So talking about electricity, we have the tools, but not only electrical tools, but we have valuable tools for software developers. The open service repository, a single access point to the platform, implemented the VMV, and also we open in Smart5Grid.eu a contact desk to ask for our support in any moment you are developing or implementing your network application, to get some more insight. Unfortunately, we skipped our guest star for today, the company Dive. because of a strong and dramatic migraine of the CTO of the company. So he is not able to join us today. What they did is translating their own system for 3D safety monitoring in a power plant or in industrial plants in general. They already had a commercial product developed with the standalone machine and leveraging on GPUs for image processing in real time. What they did, they wrote from scratch the application to within a network application, and they are ready to use our platform for the validation and verification and making all the steps of packaging these microservices, so this VNF, this software artifact, packaging them through the OSR into our network application, so that it's once again a proof of implementation for a third party who didn't know anything about 5G. They had to hire a developer to start using Cloud Edge native development techniques. But once you have a VNF, you can easily package it into a network application to be used in the platform. What we are asking for from you all is not to reinvent the wheel or making such a massive implementation. We are more than open to and likely to host any simple network application just to get familiar with the technique and learn more about the potential. Even a simple network application that it's doing a simple activity, it's a way to start using this technology. And with this point, I will open the floor for your questions and curiosity, and feel free to open the microphone and start asking questions. I can't see if somebody's raising the hand, so just open the microphone and talk. Okay, I knew that it was risky to put such a direct question to the audience. Okay, maybe you need time to digest all this amount of information. Okay, maybe there are no questions for now. Let's hope that we will have some offline feedbacks. Please consider us at your disposal for any question you might have. So, concluding our discussion and our presentation, let me summarize the key elements we developed in the project: the OSR, the VMV framework. We implemented 4 real-life demos in real power plant using real telco infrastructure. We are now implementing our roadmap for engaging third parties, and this is the 4th meeting we are having with external stakeholders. The first one with the platform available. Previously, we were just promising that shortly we will have something to play with, And this is the moment when the platform is finally available. We open contact support desk for any question you might have. And last but not least, we during the course of the project, we had a strict interaction with the 5G PPP program, of which Smart5Grid project it's a member. So get ready for the conclusion of the project. We will announce our final event in Brussels in the upcoming weeks. So before Christmas, we will have the date and the confirmation. So let me start inviting you to join us in Brussels in physical present, hopefully discussing your implementation, what we are offering to the best or more suitable network application is to advertise your artifact, your achievement to a wider, broader community. So we will bring all the most relevant network application to our final event in Brussels. Then join us on our media channel, follow us, like us, and thank you everybody for connecting and to being here today. Thank you all for participating, and goodbye.
Thank you. Bye-bye.
Thank you, Antonio.